All right, let's prepare the answer key for this quiz number 6, chapter 2, section 3. Question number 1. When an ice skater brings his hands closer to his body, which of the following will increase for ice skater? So A is mass. Mass is amount of matter. It stays constant, never changes, so this is not the answer. It will not increase. Angular momentum is conserved because the ice skater is moving or spinning on an ice, and then no torque is produced by friction force because friction is almost zero. That's why angular momentum will not change, so this is also not the answer. Moment of inertia, when he brings his arms closer to his body, and closer to the axis of rotation, when the distribution of mass gets closer to the axis of rotation, moment of inertia decreases, not increases. So this decreases, so this is not the answer. We are looking for the quantity which increases. But according to conservation of angular momentum, which is I times omega, because angular momentum is constant, no external torque acts on the ice skater, as moment of inertia decreases, angular speed increases, so answer will be B. Question number 2. A solid ball with a mass of 2 kg and a radius of 0.1 meter start from rest. This is the mass M, radius is 0.1 r. Start from rest, which means initial speed, both linear and angular speed, is 0. At the height of 5 meters, h is 5 meters, and rolls down 30 degrees slope. What is the instantaneous linear speed of the central mass of the ball when it leaves the incline? So when object is rolling on an incline, so like this is the incline, released from a height which is h, and it's rolling down on the incline and then leaving this incline, playing with some final linear speed. So we will calculate that. Remember that we are using a Hack equation for calculating this final and the final linear speed. This is the Hack equation, inside of the root 2gh divided by c plus 1. So c plus 1, c is in here because it's a solid ball. Solid ball has a moment of inertia 2 over 5 mr squared. That's why c is 2 over 5. We are going to insert all the given ages, 5 meters. So let's calculate it. V final is equal to root of bracket 2 times g is 9.81, h is 5 meters divided by c, 2 over 5 plus 1 bracket, once again bracket. So when we use this calculator, we are going to get the answer. Root of bracket 2 times 9.81 times 5 divided by, once again bracket, 2 over 5 is 0.4 plus 1, close the bracket, once again close the bracket. Answer is 8.37. So V final is equal to 8.37 meters per second. So 8.37, when it's rounded, it becomes 8.4. Answer is D. Imagine that a skater moves her arms inward, cutting the moment inertia in half. So moment of inertia changes from I to I over to cutting half, means that. How does the angular speed of the skater changes? Remember, according to conservation law, when L is constant on an ice, I and omega are inversely proportional. As I increases, omega decreases. As omega decreases, I decreases, with the same ratio even. So if angular speed initially omega, because moment of inertia, final moment of inertia is I over 2, angular speed must double. So angular speed changes by a factor of 2 because they are inversely proportional. Question number 4. A solid vertical cylinder with a moment of inertia of 5 kg/m² rotates with an angular speed of 7 radian per second about a fixed vertical axis to its center. So initial moment of inertia of the vertical cylinder is given 5. So this is the moment of inertia of cylinder. I cylinder initial. And this cylinder is rotating with an angular speed of 7 radian per second. This is the initial angular speed. A 0.5 kilogram piece of putty is dropped vertically at a point of 1.4 meter from the cylinder's center of rotation and sticks to the cylinder. Determine the final angular speed. So initially only cylinder is rotating. That's why only cylinder has or moment of inertia of the system is only cylinder's moment of inertia, because it's rotating, not piece of putty. It's rotating with an initial angular speed, but finally cylinder plus the putty is rotating. Putty is moving in a circular path. That's why moment of inertia of the putty will be calculated by mr final squared. So this is going to be the total moment of inertia of the system when the putty sticks onto the surface of the cylinder, multiplied by common speed of putty and cylinder. This is the law of conservation of angular momentum. And moment of inertia of the cylinder is constant because cylinder is a rigid object. Its moment of inertia is not changing, even x rotation is the same. Initial angular speed is 7. So finally, because the cylinder is rigid, so it's still 5 plus, but now we have an additional mass, which is putty. Putty has its own moment of inertia, which is calculated by mass of the putty 0.5. Radius of the circular path followed by the putty is 1.4, but squared multiplied by omega final. Now let's calculate this inside the bracket. So 0.5 multiplied by 1.4 squared plus 5 is equal to 5.98, almost 6. So 5 multiplied by 7, 5 multiplied by 7 is 25. 25 is equal to, inside this bracket, it's almost 6 multiplied by omega final. Divide by 6. Divide by 6, simplify 6. Omega final is going to be 35 divided by 6. 35 divided by 6. It's going to be 5.83. 5.83 radian per second. 5.83, 5.85. So this is the closest answer to this question. A student holds a 3 kilogram mass in each hand while sitting on a rotating stool. When his arms are extended horizontally, the masses are 1 meter from the axis of rotation. If the student pulls the masses horizontally to 0.3 meter from the axis of rotation, A, angular speed increases, B, angular momentum increases, C, moment of inertia increases, D, mass increases. Mass cannot increase. We know that mass is amount of matter. This is not correct. Moment of inertia does not increase because when you pull the arms closer to the axis of rotation, so moment of inertia decreases because the distribution of mass becomes closer to axis of rotation. This is also, so this is constant. Mass cannot change, but moment of inertia not increases, it decreases. It decreases because distribution of mass gets closer to the axis of rotation. Angular momentum increase is not correct because angular momentum is also constant because no external torque is acting on the student and stool. This system, nobody is pushing from outside. That's why angular momentum will stay constant. This is not correct. Angular speed increases. This is correct because as moment of inertia decreases, according to conservation law, as moment of inertia decreases, angular speed must increase to keep angular momentum constant. So this is correct answer. Angular speed increases. Question number 6. A bicycle tire of radius 0.3 and a mass of 1.5 kilograms starts rotating from rest. A net torque 6.27 Newton is required to increase the angular speed of the tire to 100 radian per second in 2 seconds. Calculate the moment of inertia of the tire. So we have two rules for calculating the bicycle tires moment of inertia. One of them is if you approximate the tire to a perfect hoop, you can use mr squared. But in this question, so because if it is not told you that the tire is approximated to a hoop, you shouldn't use that equation, which means you are going to use the equation I is equal to I times alpha for calculating the moment of inertia. Torque is given 6.75. I is the question. Let's calculate alpha. Alpha, we are going to use definition of the angular acceleration, which is final angular speed minus initial angular speed divided by delta t. And 6.2775 is equal to I times final angular speed is 100. Initial is 0 because it's starting from rest. So initial is 0. Divided by delta t is 2 seconds. So which becomes 100 or divided by 2 is 50. Then I is going to be 6.75 divided by 50. So if we do that, 6.75 divided by 50 is equal to 0.135 kilogram meter squared. Answer is in here D. Calculate the rotational kinetic energy of 150 gram football of radius 10 centimeter rotating at 160 radians per second about its center. So we are going to treat this football as a spherical shell about symmetry diameter. So that's why moment of inertia equation is 2 over 3 mr squared. Okay, let's calculate rotational kinetic energy. Kinetic energy rotational is equal to 1 over 2 I omega squared. First, let's get I. I is 2 over 3 mr squared. 2 over 3 m is 150, so which means 0.15 kilogram multiplied by r 10 centimeter, which is 0.1 squared. So let's calculate the moment of inertia. 2 over 3 multiplied by 0.15 multiplied by 0.1 squared is equal to 0.001 kilogram meter squared is the moment of inertia. Now let's calculate now rotational kinetic energy. 1 over 2 multiplied by 0.001 multiplied by omega, which is 160 but squared. So multiplied by 160 squared divided by 2, which is equal to 12.8 joule is the answer of this question. So 12.8 joule, how did we get this? Well, I don't know, but there's a mistake in the choices. I'm going to check this question again. So next one is a solid ball, a solid disc, a ring starts at a height of 3 meters and rolls down 20 degrees slope at the same time. So a solid ball, a solid disc, a ring starts at the height of 3 meters, rolls down 20 degrees altitude at the same time. Both the ring and disc have the same mass reduced as the ball. Which of the three objects will arrive to the bottom last if all roll without slipping? So according to the if an object or objects are rolling on an incline, if the question is how fast it's moving, it's about calculating the translational speed at the bottom of the incline. The one which is faster will arrive the bottom first, the earlier. So we are going to get this final speed as equation 2gh divided by c plus 1. And this equation tells you that if you want one object to be fastest, it's c, moment of inertia, coefficient of moment of inertia must be smallest. And from solid ball, solid disc and ring, solid ball is 2 over 5. Solid disc is 1 over 2. Ring is 1. These are the coefficients of moment of inertia, because this is equal to mr squared. It is 1 over 2 mr squared. This is 2 over 5 mr squared. So these are c's. And when you check them, C is for the solid ball, it is the smallest C. I mean, the solid ball is fastest. That's why the solid ball is the first. But the question is asking which one is last. I mean, the one which has the greatest moment of inertia, the greatest coefficient of moment of inertia, which is 1. The ring will be the last arriving the bottom of the incline. Blah 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 is a measure of the object's resistance to a change in rotational motion about some axis. This is the definition of moment of inertia. So answer is C. Moment of inertia on object depends on mass of the object, shape of the object, and axis of rotation. Yes, all of them is correct. The greater the object's moment inertia, it is easier to rotate the object, harder to rotate the object, either easier or harder, no difference. So greater moment of inertia, harder to rotate the object. A solid vertical cylinder of mass 2 kg and radius of 0.5 meters rotates with an angular speed of 7 radians per second about a fixed vertical axis to its center. Calculate angular momentum. So angular momentum is I times omega. I must be first calculated. Let's calculate I. 1 over 2 of the mass of the cylinder to moment of inertia of the angular radius of the cylinder is 0.25 but squared. These two will simplify. 0.25 squared is how much? Let's get it. 0.25 squared is equal to 0.0625 kilogram meter squared. So then let's calculate angular momentum. I is 0.0625. Angular speed is, moment of inertia is 0.0625. Angular speed is 7. When you will multiply these two numbers, answer is 0.437 kilogram meter squared per second. So answer is 0.44. B is the correct answer. Show the following represents Newton's second law for rotation. Newton's second law for rotation is torque is equal to I times alpha. I times alpha, it's about the torque. This B is the correct answer because alpha can also be written as delta omega over delta t. Remember, change in angular speed divided by delta t is also known as alpha. So this is the Newton's second law for an alternative writing for Newton's second law for rotation. Question number 14. A potter's wheel that has the shape of a disc of radius 0.5 and the mass is 100 kg is freely rotating. The potter can slow down rotation of the wheel with an angular acceleration of magnitude 2.6 radians per second squared. How much torque does the potter apply to the wheel? So torque is equal to I times alpha. So this is the shape of the disc. Disc has a moment of inertia equation 1 over 2 mr squared. We need to first calculate what this moment of inertia is. Moment of inertia of the disc 1 over 2. Mass is 100. R is 0.5 watt squared. So let's calculate this. 0.5 square 0.25 multiplied by 100 is 25 divided by 2, 12.5 kilogram meter squared is the moment of inertia. Now let's get it. I is 12.5, but angular acceleration is positive or negative because it's slowing down. Slowing down, magnitude is always positive, but when it slows down, you should write alpha as negative 2.6. So multiply 12.5 multiplied by 2.6, negative 2.6 is answer is torque is equal to negative 32.5 Newton meter. So B is the correct answer. A tin hoop rolls along a horizontal smooth surface at a constant linear speed without slipping. The ratio between the rotational kinetic energy about central mass 2. Its total kinetic energy is equal to. So kinetic energy rotational divided by kinetic energy total. Remember, there is an equation C divided by C plus 1. So this is a tin hoop. For tin hoop, C is equal to 1 because moment of inertia equation is mr squared. And here 1, that's why C is 1. So let's write 1 in here. 1 divided by 1 plus 1, which becomes 1 over 2. B is the correct answer. And question number 16, as the angular speed of an object doubles, its rotational kinetic energy changes by. So let's write the equation. Only angular speed is doubling. Equation for rotational kinetic energy. We know that rotational kinetic energy equation, kinetic energy rotational, is 1 over 2 I omega squared, which means rotational kinetic energy is proportional to omega squared. If you double the omega, if omega is doubled, so 2 omega, but you should square not only omega but 2 as well, it becomes 4 omega squared. If the right side increases by 4, left side of the proportional to also increase by 4. That's why 4 times kinetic energy rotational. So answer is B. So rotational kinetic energy changes by a factor of 4. A cylinder of mass 500 gram and radius 30 centimeter rolls on a flat surface. The instantaneous linear speed of the central mass of the cylinder is 4 radian per second. Calculate the total kinetic energy of the cylinder. For a rolling object, if the instantaneous linear speed is known, you can calculate it by total kinetic energy. Kinetic energy total is equal to 1 over 2 mv squared multiplied by c plus 1. Again, c, cylinder as an equation, moment of inertia equation, 1 over 2 mr squared, and this is c, 1 over 2. So let's write the given 1 over 2 m. Mass of the cylinder is 500 gram, 0.5. Instantaneous linear speed of the central mass is 4 square root of 4. C is 1 over 2, 0.5 plus 1. So let's use the calculator and then get the answer. 1 over 2 is 0.5 multiplied by once again 0.5 multiplied by square root of 4 multiplied by 0.5 plus 1, which is equal to 1.5. So all multiplied, answer is 6 joule. 6 joule is the answer. Answer is not in here. There is a mistake again, so I'm going to change it and then give you this changed one as the question. So we got the answer 6 in here, total kinetic energy. And a solid ball with a mass of 4.1 kilogram and a radius of 4.05 meters start from rest. This is mass, and this is the radius, and start from rest means initial angular speed, initial translational speed is 0. Height is 2 meters, age is 2 meters, rolls down 2 degrees. So how much is the total mechanical energy of the ball at the top of the incline? So at the top of the incline, because there is no angular speed or no translational speed, that's why kinetic energies are 0. Energy at the top, mechanical energy at the top only is equal to potential energy mgh. Because you know what h is given as 2 meters, and also you know what mass is given as 4.1. Just use the equation for potential energy. 4.1 is the mass, which is 9.81. Age is 2 meters. When you multiply them all, you will get the correct answer. 4.1 multiplied by 9.81 multiplied by 2, which is equal to 80 joule. 80 joule is the correct answer, which is D, or 80.4, yeah. Question number 19. A bicycle designer recently modified a bicycle by adding cylindrical weights to the spokes of the wheels. This would make the wheel easier to rotate, the moment inertia greater. This is correct. Moment inertia gets greater because if you add mass, because moment inertia proportional to mass, when you add mass to a system, you increase moment inertia. Only exception is if you add the mass exactly to the axis of rotation. I mean, the mass is going to be so thin, and you will add all this mass to axis of rotation, so you can say that moment inertia does not change. But other cases, when you add masses to the spokes of the wheels are not axis of rotation. That's why as mass increases, moment inertia increases. Moment inertia gets greater. This is correct answer. As moment inertia gets greater, the wheel will be harder to rotate. So this must be harder to rotate. That's why this is not correct. Total mass, the total mass gets smaller. This will make total mass smaller. No, when you add masses, weights, mass increases. This is not correct. So correct answer is B. A solid ball, a solid disc, and a ring are released from the rest from the top of an incline at the same time. Which one will win the race? So solid ball, solid disc, and a ring are released from the rest from the top of an incline at the same time. Which one will win the race? Of course, the one with a smaller c, solid ball, will win the race. Smaller c, because solid ball has a c2/5 mr squared, so this is c for solid ball. Solid disc is 1/2 mr squared, so this is less, smaller, greater, because this is 0.4, this is 0.5. But ring is mr squared. Ring has the greatest c, c is 1. That's why the solid ball is the first. It's going to win the race. Maybe I should change this question to an alternative form if I change it. So in the quiz, maybe I should change to the comparison of the rotational kinetic energies or translational kinetic energies. Okay, this is all about quiz. And when I was checking the quiz, if there's some mistake, I also prepared the answer key of this quiz, and also I am going to make some change in the questions, and then I'm going to give these questions to you as a quiz. See you in the next one.